So how do you look at the relationship between a categorical variable and another categorical variable? Well, to start, we've already looked at how to describe that within the sample, right? So let's say we had something where we had a question on a survey. We were asking people their opinion, strongly disagree to strongly agree to a statement about school choice, particularly the idea that uh, the ability for parents to choose the school they go to has had a positive impact on student achievement. To what extent do you agree with this statement, where the choices were strongly disagree to strongly agree? And then on the same survey, we also asked them, say, their party affiliation, Democrat, Republican, Independent, and we also gave them the opportunity to not provide a party affiliation. Well, we already know how to look at the relationship between the two because what we have here is a categorical variable and another categorical variable. How do you actually look at the relationship between those two things? You make a cross tabulation, also known as a contingency table, right? And so with this crosstab, remember it's just a really simple way to summarize that information in your sample, and we like it a lot for many reasons, right? And so the question becomes, how do you statistically test, though, if there's a relationship between these two constructs? Well, we have a test for that too. That test is called the chi-squared test of independence, right? Where chi is spelled C-H-I, and so it's the chi-square test. And chi is a Greek letter. It looks like this kind of lowercase, squiggly x there. So you might see it with a symbol, you might see it spelled out. Either way, it's the same test, right? So the chi-square test of independence is saying, can we see whether or not we believe there is a relationship between these two categorical variables in the population? So what's the null and alternative hypothesis, as always, right? Because we're trying to figure out if there's a relationship between the two things. The null hypothesis is there's no relationship. The alternative hypothesis is that there is some relationship. Simple as that. Now you might say, like, we were using Greek symbols and all of that before. Like, why aren't we using it here? Part of it is that it's kind of hard to describe symbolically the relationship between a categorical variable and another categorical variable, and there are many reasons why it's actually difficult that we're not going to get into here. But just like we haven't come up with a good symbolic way to write that out, and so we actually just write it out in words in a way that's often a lot more easy to understand. Null hypothesis, no relationship. Alternative hypothesis, some relationship, right? And so we want to be able to figure out, are we going with the null hypothesis or are we going with the alternative hypothesis? How do you do that? This is the same thing we've always done, right? First, you calculate your descriptive statistic. In this case, the descriptive statistic is the crosstab or the contingency table. That's it. Then, in order to do the chi-square test of independence, we actually look at like the relative overlap of the different categories, right? Which you can imagine is what we're talking about when we talk about the pattern, right? We're looking at the extent to which certain categories overlap with other categories, right? And then we calculate from those overlaps something that we call the chi-squared statistic. Just like the t statistic, just like the f statistic, it's just another statistic that is kind of a pass-through for us to be able to translate it into a p-value, which is what we do. We calculate the chi-squared statistic, we translate it into the p-value, and then you interpret that p-value the same way you've always done. So let's say we ran a chi-square test of independence for this relationship that we were talking about. And let's say that we did all of that, or the software did all of that, and we got a p-value of 0.03, right? Or 0.003, sorry, right? Well, 0.003 is less than our traditional threshold of 0.05, and so what we would conclude is that we would reject the null hypothesis, that there is no relationship, right? Or in other words, we come to the reasonable conclusion, or we can come to the reasonable conclusion that we think there is a relationship between people's opinions on this particular survey item and their party affiliation. And that's really all it is. That's the chi-square test of independence, testing the relationship between a categorical variable and another categorical variable.